This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Sven Johann for Software Engineering Radio. Today I have with me Andrew Phillips. He heads up product management at Xebia Labs. Andrew is an evangelist and thought leader in the DevOps, cloud, and application release automation space. He sits on the management team of Xebia Labs and drives product direction, positioning, and planning. Today, I will be talking with Andrew about DevOps. Andrew, welcome to the show.
Thank you, Sven. I'm glad to be here. That makes me sound so kind of important. I like to joke that, yes, officially I'm the VP of product, but just so people don't get concerned and think I can only make PowerPoint presentations. I also try and spend a lot of my time remembering what real life is like. So I'm a member of the Apache Software Foundation. I work on a bunch of open source projects. I collect Scala puzzlers. So from time to time, usually between 10 and 2 in the morning, I actually manage to get my hands dirty and do real stuff. And luckily, my girlfriend's a software developer, so she kind of understands.
Okay, good. What projects at the Apache Software Foundation?
I'm currently the VP for Apache JClouds. And I've worked on a bunch of other things in the past. I worked a bit on Multiverse, which was an original software transactional memory system that was inside Akka. Or Akka, as I don't want to pronounce it, I can't pronounce it properly. Jonas Bonner will have to do that. It's a Scala and Java library. And I've committed a few things to things like Gradle and a few other of the bigger open source projects. I have my name on some of the commits in the Scala source code, etc.
Okay, let's get started. What is DevOps?
How much time do we have?
50 minutes.
Okay, well, let's try and keep it short then. I think the big problem today is that actually, if you're coming at this space very new, it's almost impossible to get a sane and simple answer to this question because, of course, so many people are jumping onto this bandwagon and trying to claim that it's their own. I sometimes like to joke that, if you make a screwdriver nowadays, and it's for installing racks, people will call it a DevOps screwdriver. So from my perspective, in terms of trying to keep it simple, what I would say is that it's basically an attempt to try to understand that the world of software development goes beyond just writing the code. If you like, it's taking those agile principles that we've mainly adopted in the industry now and realizing that the Scrum board extends beyond where it typically goes. It actually goes into how do I get this new piece of code out into production. So, one of the original formulations, in fact, the famous original Post-it note at a conference was Agile Operations. And so I think having that in mind as a kind of, applying Agile principles to operations is a good way to think about this. I think, more generally, anybody who's worked, got their hands dirty with software development realizes that a lot of the problems that we face come from the fact that development and operations, and of course other groups as well, QA and security and so on, really don't know enough about what the other group does. It's very common in organizations to have operations teams trying to run applications that they do not understand at all. They don't know what it does, who the users are, roughly how the application works. And similarly, developers, and plenty of developers who only know how to set up the system on their laptop and have no idea what the overall production architecture looks like. And these things cause plenty of problems, and so people who've had to live on both sides of the fence realize that we can make stuff a lot better by having more mutual understanding. And that's really, I think, ultimately where DevOps comes from and what it tries to do.
So that sounds that DevOps has a relationship to Lean.
Go on.
Sorry?
Go on, I thought you weren't finished with your question.
Yeah, because Lean says, well, we have to look at the whole value chain. And if you only look at, for instance, Scrum stops at delivering features and it doesn't bring anything into production. So, we have a bottleneck.
Exactly. And I think, I think you're right. And I think especially what we've seen over the past few years, is the convergence of a lot of terms that actually look at this process more fundamentally, whether it's continuous delivery or lean, and I'm sure we'll get into that in a bit more detail. I think the origins are a little different. I mean, lean makes the process very explicit and very first class. I think a lot of the drivers of DevOps originally, and that has changed over the years, were almost emotional. They were like, we're suffering together and we can make our lives better. And I think in a lot of cases, if you asked the original proponents of DevOps, what are you actually trying to do? They wouldn't necessarily have turned around and said, we want to optimize the end-to-end process of software delivery. That's really what continuous delivery and lean to some extent were all about. It was more like, we are suffering a lot because we don't work together enough, and we can make this better by collaborating more. But of course, over the years, as companies especially, and vendors and analysts have tried to make DevOps more business friendly and to try to attach very concrete, return on investment kind of terms to it. The idea that this sort of hippie style language, if we all cuddle each other more, then life will get better, that doesn't sound very compelling to a CIO. So you have to attach all these very concrete metrics to it, things like, accelerating time to market, reducing waste, yada, yada, yada. And especially once you start to bring those kind of terms, it becomes very difficult to distinguish something like DevOps from continuous delivery or lean, indeed.
Okay. What are then the goals of DevOps?
So, I mean, without trying to repeat myself too much, I think originally the goal was genuinely trying to, make life better for the people at the coalface for both development and operation by increasing mutual understanding and also mutual trust and collaboration. Because once you get a picture for what used to be the enemy, you can find better ways of working together and of helping each other. I think if you look at, if you pick up a Gartner sheet, or you read some of the blog posts or the white papers nowadays, people will say more likely that the goal of DevOps is like to accelerate time to market, to reduce costs, to reduce error rates, to speed up innovation, these kind of very business-friendly terms. I don't think that necessarily was the original goal, but I think that's the goal as it's presented often nowadays. In practice, what happens a lot is that people recast the goal of DevOps as being, we need to introduce 5,000 automation tools. Because the goals are very easy to state, but of course what people need to do, if they now decide that this sounds great and they want to adopt DevOps, they need to figure out, well, what do I have to do now? Where do I start? And very often the most visible part of a DevOps implementation is the use of a whole bunch of very cool tools, whether it's Puppet or Chef or Nagios or App Dynamics or whatever. Those are the very kind of obvious, visible things. And so people tend to pick those as being the things that they're going to get started with. But I'm always one who's very careful to state, tooling and automation is not a goal of DevOps. It might be something you want to do to help achieve what you're trying to achieve, but it's really a means to an end and not the end in itself.
You mentioned that most companies then start with buying tools if they want to do DevOps, and that's obviously wrong. But what is right? How should I get started?
Well, and there I think Lean actually has one of the best and most obvious prescriptions for how to get started. I've sometimes, certainly recently when talking to people who ask me this question, I say, look, let's ignore all the terminology. What do you actually want to achieve? And I think the interesting thing is that the goals, once you really start asking about them, they're not generic. They really depend on the kind of company or the context you're working in. I mean, I can talk about ourselves as a very trivial example. Like, we're a software vendor, we write software tools. Of course, we want to optimize the process of delivering our tools as well. We want to have as little friction as possible in the development and delivery process. But our customers would not want a release every 5 minutes because they run the software on-prem. Like, if we told them, look, we're going to push out a new update every 5 minutes, they would go crazy. Similarly, there's a very interesting presentation by a CIO from GE Capital, and he said, look, the goals that they chose for their DevOps initiative were, faster whiteboard to production time, as they termed it, so taking ideas and getting them actually to their users. Whiteboard to production time, I think a lower error rate was what he was mentioning, like getting it end to end without breaking so often. And the third one, which was very interesting, was reducing the time it takes to provide audit answers. And this is, I think, an interesting example of a very industry-specific problem. Like if you're in retail, for instance, answering questions from auditors isn't a big pain point for you in general. But if you're in the financial world, it's a really big problem. And so they deliberately engineered their process and their tool choices and the collaboration and the security model and so on to allow them to optimize for this problem. So I think, I mean, of course, it's a very scary kind of consulting answer to say, well, it depends. What's the right way to do it? I think the right way to do it is indeed to start with a clear and shared definition of what you're trying to achieve. What are the metrics that we're actually trying to optimize for? And then I think the notion of a value stream mapping and the way Lean does it is a very good way to start. You actually try to understand, what do we do today from taking an idea and actually getting it running in production? Because ironically, in a lot of organizations, you'll find that nobody has the full picture. Like the developers know how it's developed, and maybe the release team knows how it's released, but that whole end-to-end picture is often missing. And once you have that end-to-end picture, this rain is getting really loud, so maybe we should move somewhere else. But once you have that end-to-end picture, then you can start to see where the waste is. And you can also start to see, where do we need to actually optimize? In practice, I think this is the right way to do it. I think the challenge with that is that it can be very scary for organizations to take such a big scope, because if you go to a big organization, production may be run by an outsourced company, development may be partially outsourced depending on which systems you're talking about. There's all kinds of different departments involved. So to take this really high-level view is a very difficult thing to do if you're trying to grow and start small. You really need to take this sort of enterprise transformation concept, and that's very scary for a lot of big companies. So typically, if I talk about what's realistic to do in a small environment, obviously pick a couple of projects or teams, and then the team itself will probably have a pretty good idea of what's going wrong right now. How long does it take them to deploy an application? How long does it take them to spin up a testing environment? What's the error rate going forward to production? Blah, 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 blah. So without doing any really complicated analyses, you can pretty quickly identify what the big problems are, and you can typically pick tools to try to help with those. Now, tooling isn't always the solution to these problems, but by and large, the vast majority of problems that people are facing in this overall chain can be made better by tools. I mean, if you're still sending an email to someone in a different department to please pick up this binary from a shared folder and copy it onto a production server, it's pretty clear that that process can easily be optimized. So I think, it sounds ridiculous to imagine that is the status quo, but I think by and large, that for a lot of people, that is the status quo.
Okay, you mentioned value stream analysis. That sounds also like a value stream analysis is a typical Lean tool, right? So that Absolutely. Is then also a commonality.
Yeah.
Okay, and you mentioned one of the goals is to bring whiteboard ideas into production. I heard that quite often from the continuous delivery camp. What's the relationship between DevOps and continuous delivery? Is it the same?
Well, let me answer this in two ways. Unfortunately, I think for the vast majority of people who are entering the space today and who haven't been through the sort of 5 years of development of the two terms, the easiest way to understand it is to claim that, or to just accept that people use the terms almost interchangeably. Some people say continuous delivery is the goal of DevOps. Some people say DevOps is the key thing you need to do to get continuous delivery running. I don't think either of them are necessarily quote unquote true if you go back to the original origins, but frankly, it's almost not worth arguing that point, because ultimately, what the majority messaging is, to some extent, that is what people will hear. So I think nowadays, unfortunately, these terms are used almost synonymously. So some of the things that continuous delivery is a fairly prescriptive, process-oriented framework. It doesn't really, if you read the book, if you like, it doesn't talk all that much about, how collaboration between departments produces a better environment for all. It says, look, really what we care about is optimizing the end-to-end process so that you can release smaller batches of changes more efficiently, more quickly, and that has all the benefits that we've all heard about. It reduces the risk, it allows you to innovate faster. Everything is perfect, right? Obviously not quite true, but I think that's the sort of bigger picture there. And very often people that have tried to implement this end-to-end process realize, and this gets into the whole kind of systems thinking type idea, once you start to explicitly talk about the end-to-end pipeline or process, you realize that you basically need to have everybody who's involved understanding the process. So you're pretty quickly at the kind of product team concept or systems thinking concept. I think some of the things that are not typically talked about in a continuous delivery environment, but that are very, well, from my perspective, very much part of like DevOps thinking, is the notion that, you know, we're all friends to some extent. Not just because that's more efficient, but because we're actually all writing software at different parts of the stack. We all have, you know, techniques that can basically be applied to each other, and actually pretending, you know, if we're different and we're sort of enemies is not really helping anybody. I mean, let's face it, that maybe the biggest change in the past 10 years in operations is not something like DevOps or continuous delivery. It's simply the fact that we have shifted from being a physical logistical job of actually moving boxes around and installing them in data centers and stuff like that. Operations nowadays is largely a software development job. Like, all the stuff you're doing is virtual. You're defining virtual servers, virtual networks, virtual bridges, virtual DNS, all this kind of stuff. And so obviously all the things that we've spent 15, 20, 30 years learning from app tier, quote unquote, software development, things like, you know, unit testing, continuous integration, modularization, they all apply to modern day operational development as well. So since we're both doing development to some extent, it doesn't make sense to say, well, we're not going to share experiences here. And so I think, you know, a lot of the things, you know, there's a few questions I used to like to ask when people say, look, we do DevOps. I typically did not try to ask about tooling. I would ask things like, you know, when was the last time your average app developer had a beer with someone from operations? Or how easy is it in your organization to have your production DBA sitting in a planning meeting or a sprint review or something, so that they can help you understand, you know, something like, very true, you know, simple practical example. You're building your system on your laptop based on the assumption that your database lives on the same system, so the latency is very, very low. If you understand that in your production environment, your database may be in another data center with a certain level of latency in between, that obviously can have an impact on how you architect and develop your application. But this is the kind of like simple shared knowledge that in many cases isn't present. Mm-hmm. And then you get into the classic problem that you run a load test in the pre-production environment one day before you're due to go live, and you discover that the application just falls apart because it's making 10,000 queries, and each of them takes half a second to respond or whatever. So I mean, DevOps, I think, originally was very much about, look, we've learned that this happens in real life. What can we do at the process level, at the human level, also at the tooling level, to try to eliminate these problems?
Okay, so it's basically bringing every technically responsible person for the end-to-end process in more or less one room or into one team.
Exactly. And I think because that's why I think ultimately, if you start to think enough about all of them, they all converge to the same thing, because even if you start with a team, you bring all the people into a room, well, what do you end up talking about? You end up talking about the end-to-end process. Similarly, if you start with the goal of the end-to-end process, which is where continuous delivery would start from, and you then figure out, well, what does it take to understand and optimize this end-to-end process? Pretty quickly, you need to figure out you have all the people in the room. So you end up at kind of the same point, and I think that's what we're seeing right now. And of course, ironically, with Agile, it's kind of the same thing. I mean, people nowadays talk of continuous delivery and Agile as if they were two things, but one of the slides I like to put up in my presentations is the following quote, like, the most important thing is the continuous delivery of valuable software to our customers. And that's principle number one from the Agile Manifesto. Mm-hmm. So, you know, it's not like version 2 of Agile. It's actually right in there in version 1. It's just that, of course, most people don't do this because Agile started out within the development department and it sort of stopped where the quote-unquote boundaries of the development department tended to stop.
Yeah, exactly. Yeah, that's what I heard quite often, that DevOps is actually post-agilism. So we had Agile software development, but it stopped after accepted features. Mm-hmm. Yeah, but then it has to go somehow in production, and that was then obviously a problem because we had barriers, and these DevOps just broke that barriers down.
Yeah,
and
exactly.
I think Werner Vogels, the CTO of Amazon, he once said that the teams at Amazon, they have a simple rule: they build the software, and the same team which builds the software also runs the software. So you build it, you run it. That's one of his famous quotes. And that is basically an early DevOps team, right?
Yeah, I mean, early DevOps teams, of course, this goes way back. Like, think back to mainframe development. They built it and run it as well. So, I mean, to some extent, this is nothing new. We've historically, and for lots of types of very specialist systems, there was never this distinction between building and running, because the people who had the expertise to build stuff were also the people who ended up running it. It's only as we started to, if you like, consider operations as some kind of outsourced separate function like a utility, which would take care of all the underlying stuff, and then we would just shove applications into there, and it didn't really matter whether the team that provided the foundation really understood about the application, that this started to get split. And of course, yes, as you say, it's that classic, you build it, you run it, or you get the pager. Those kind of things, they immediately force people to think about the operational aspects. Like, one of the examples from Amazon is very classic, and this is a sort of classic DevOps metric, if you like, that as soon as you start to get the thing that wakes you up at 3 a.m, the number of logging statements and the number of operational supporting features in your code, like health check pages and all this kind of stuff, goes up dramatically. And of course, the one easy way to enforce this is to make the developers feel the pain. But even if you're not in a position to do that, because of course, for a lot of organizations, the development might be outsourced, or they're working in a time zone that is different from your customers, so it's very difficult to get them to do production support or whatever. You can still try to, it's a very important metric. So you can always ask yourself, how easy is it in your organization for somebody from operations to actually put a feature request on the backlog of a development team and say, look, we're really struggling with your application because when it goes down, we have zero idea of what's going on. It's a very common problem. And to what extent is your organization able to address it? Like, even if they do put in a feature, is there any chance of it ever getting implemented? These kind of things are very good examples for how much you regard the building and running of a system as being two sides of the same coin, as opposed to two totally separate problems.
We talked about Amazon and what DevOps means to them, but I can imagine that different companies do understand different things about DevOps. So I think you also mentioned that different companies have different problems they solve. Can you give a few examples?
Yeah, sure. I think unfortunately the biggest class, it's just like with Agile. Like we're seeing the same kind of evolution. With Agile, I think, I don't know what the exact estimates right now are, but Agile is supposedly the majority software development methodology in the world. More than 50% of projects are run this way. But I think we all know that probably at least 49% of those projects, when they say Agile, they mean we have a Scrum board and we pay lots of money for Post-it notes and we stand up at 8 o'clock in the morning rather than, sitting down. But otherwise, we effectively have a waterfall process, et cetera, et cetera, et cetera. So one of the problems with any kind of strategy or any kind of philosophy, almost methodology like DevOps or Agile, is that adopting it late usually means you try to look at what the people who are supposedly doing it successfully are doing, and you just copycat what they're doing. So yes, you'll install Puppet Chef, and then you'll get Jenkins, and you might, whatever, you might install, I don't know, HipChat or something, and suddenly you think you're doing DevOps. But that's not, the vast majority of DevOps implementations look like this. And I don't think that's the fault of the companies. I mean, I think that's part of the challenge for the industry, is to, because the reaction to this is usually that people say, yes, but of course you're not supposed to copy us. You're supposed to learn the way we think.
Yeah, I think that's a very interesting point. I read a lot of lean publications, and they also say they see Toyota, or they see what Toyota is doing in the US, and they say, okay, we perfectly copy what they do to our production plant. And it just goes horribly wrong, and for the same reasons you say, it's not a cookbook.
Exactly, and I mean, I think a lot, and I think as people trying to promote this concept in the space, we have two duties. One, to point out that it's not a cookbook, but that is only partially helpful, because let's face it, most people who work for large organizations are not stupid. It's not that they don't know this. It's just that, if you haven't been deeply involved in a field, you can't just sort of absorb the thinking of a field by reading a book in a couple of days, right? It takes time and practice. And of course, a lot of the, if you like, the picture, the sort of textbook examples of companies don't have a lot of the challenges that big companies have. Like, so one of the classic comments we always get is like, yes, sure, Etsy or Amazon or Facebook or whatever. No, that's not the environment that 95% of these other companies are working in. All the companies I've just mentioned have a tremendous abundance of technical talent. The notion of having to work with people who maybe aren't the smartest or whatever, that doesn't exist there. There's not that much of a struggle to hold on to good people. You can trust them to wrestle their way around every tool that they come across. You can trust them to write their own tools if necessary. And the organizations are pretty young and pretty flexible. That is not the situation that a bank, for instance, is typically in. Like, they don't have to deal with 8 different vendors running different systems that have been around for 35 years, with only 3 people who still understand how they work, difficulty retaining talent, etc., etc. So I think it's not just about saying, don't believe in a cookbook. It's also about trying to understand, well, how can we make it easy for you to understand what you should be doing? And I think to me, the big lesson, I mean, to some extent I already said some of this, the first is to recognize that in pretty much whatever industry you're in, largely both development and operations are basically doing software development. So make sure you apply the same kind of lessons to both. And then you, as an organization, I think right now you have a choice. You have a choice to try to merge those two development streams together, to do the kind of full stack deployment model, which is something companies like Facebook or Netflix are typical examples of. Basically, there is no more distinction between the platform on which your stuff runs and the application. It's just a big deliverable, like version 3.5 of my system. And that is everything, from the operating systems and the networks and the DNS settings, all the way through to the application code and the stuff on top of that. And the other model, which also big companies, I mean, so Google, for instance, at Google as a developer, you have no idea how your stuff runs in production. It just works. It goes in some container, you don't see it, magic. Brilliant if you're a developer, because it just works. But there's a very distinct split there. I think as a company, you need to make that kind of decision. And I think the other thing you need to do as a company is every company recognizes immediately that if there were a better communication and a better understanding between development and operations and security and QA, of course, and all these other departments, things could be better. But I think that the way every company should perhaps best approach this, and this gets back a little bit to the value stream mapping, well, what are the 3 biggest problems? Like, what are is it that the developers don't understand how the thing runs in production? Is it that developers don't have any idea of the security requirements that need to be met? Is it that the systems that you build are totally unauditable because of all these manual processes that you're doing, and that's a big pain point? And once you understand where the biggest knowledge gaps are, most companies have a pretty good idea of what could be done to fix them. That doesn't mean that is possible, because in some cases it might mean you have to fly people halfway across the world every 2 weeks, and that's unlikely to be feasible. But I think if you regard DevOps as, DevOps is a way of, trying to identify and tackle the biggest problems resulting from, mismatches in understanding and process between development, security, QA, operations, and so on, then you also have a pretty good blueprint for what you need to do to fix it. Because I can't tell you as a company what your 3 biggest problems are. I can tell you what you should look for, but you need to identify those problems themselves. And then, of course, once you've identified the problems, sure, I can come with some experience about how other companies have tried to tackle these problems in the past. And then, rather than having to do the heavy lifting of trying to identify possible solutions, then we can say, yeah, you might want to look at this tool, or you might want to look at this technique, or whatever. So I think that's a good way of starting. Think of this as identify the biggest knowledge gaps, the biggest process gaps in that overall system, that end-to-end process, and then figure out which are the ones that you can realistically solve. You don't have to solve all of them at the same time.
But is there a specific culture needed to succeed with DevOps?
Yeah, is there a specific culture that's needed to achieve any kind of these? I think the one thing that is perhaps the most important is that you're never it's going to be very difficult for people to be motivated to solve what's essentially an end-to-end problem if your organization is very, well, not saying negative, but it is not very, it doesn't foster end-to-end thinking. If you're in an the classic example being, if you're in an organization where, an operator is paid or given a bonus purely on the percentage of uptime, and the developer is paid based on the number of new features that are delivered, then even though they both understand that these metrics put them in competition, it's very difficult to expect them to sort of magically say, well, I'm going to risk half my bonus because I think it will be better for everybody. You have to obviously put the organization and the teams in a position where it makes sense for them to go in this direction. And so that might be to say something as simple as, look, we're not going to measure you on this and you on that, but we're going to measure both of you together based on the number of customers that we gain, or the reduced number of outages that we have, but then divided by features that we've delivered, or something like that. So at least we can, one of the things I wrote a blog post that got me shot down a few years ago, which was about 99.99999% uptime isn't necessarily the right thing for everyone, because in most situations it comes at the cost of your ability to innovate. And speed of change and stability, to some extent, they're two sides of a trade-off. And every company, every project maybe even, should figure out where they want to set that trade-off. Maybe they want to try new stuff all the time, and it doesn't matter so much if it breaks. Maybe they're a financial services company, and it's much more important that stuff doesn't break, because if it does break, then they go bankrupt. Right? That changes your perspective on being risk tolerant. But no, I think going back to your question, what kind of culture is needed? You need a culture that, and Gene Kim obviously talked about this a little bit, you need a culture of experimentation and learning. You need a culture that recognizes the fact that things are not perfect, where turning around and saying, this is something we could improve, even if it's not your personal area of responsibility, is valued and is not immediately shot down as like trying to tell other people how to do their job. And of course, not just where such behavior is encouraged, but also where there is the ability to act on it. Because even the most well-intentioned people, once you've given 50 suggestions and all that happens with them is that they disappear in the black hole of nothingness, like you give up.
Of course, yeah. Yeah, and also, the culture of experimentation actually fits very well what we said, that you cannot copycat. Everybody has to find his own way.
Exactly, and I think you're right. It's not possible to copy the same solutions in the same order from another company, and that doesn't mean, maybe we should be careful here. That doesn't mean that for the similar, most companies have similar kind of problems in general. Like, the classic ones, it's impossible to get a test environment up and running with a realistic data set. That is a problem that 85, 95, however many % of projects have. So And if you identify this as a problem, then the solutions aren't going to be unique to you in general. It's perfectly acceptable to look at how other people have solved this problem. I think what should not be copied is the order and the priority of those problems. Now, for some companies, that might be the biggest bottleneck that you have, and so you should tackle it first. But that doesn't mean that in a different context, you need to do that thing first because the other team did it first. Your problem might be that the coffee in your coffee machine is terrible, so everybody keeps falling asleep when you're having your production status meeting, and then they all miss the updates about the database having blown up. I mean, of course, that's an ironic example, but it's, it's not as though we can't learn from each other. It's just that the sequence in which we need to apply particular, fix particular problems will depend A, on the context we're in, and B, on what we're actually trying to optimize for. So, I mean, in the same way, like obviously if you go, if you take two hospitals, doctors that get two patients with the same kind of problem, you would hope that they apply more or less the same kind of best practice approach, obviously taking into account variables such as the age of the patient or whether male or female or whatever. But if you get two complicated, like car crash victims, which is unfortunately typically the case of what happens in the software development, doctors will not treat them in exactly the same sequence because one of them will have a broken leg and the other one will have a punctured lung. And so, I think that's what we have to see. It's like at a larger picture, the problems have different priorities. And once we can agree on what the priorities are, then we can start to say, well, okay, so if this is the most important thing to solve, what would be a good solution for this? Do some of the solutions that other people have tried, do they fit our problem, our context? Or maybe if they don't, we need to try something else. So, I mean, and then from a software, since we're doing software development radio, it's a bit like saying, if you've identified that your application, that logging is a problem, obviously you shouldn't go and write your own logging framework unless you've discovered that your landscape is so complicated that neither SLF4j, nor log4j, nor commons logging, nor whatever will work for you. This is a Java example. But that just because I've stated that there are pretty good solutions for the logging problem, it doesn't mean that every software development project now should go and put logging at the top of their backlog.
The Agile software development movement, they wrote down certain practices I can orient myself at. Does DevOps also offer something like that? DevOps practices?
Yeah, I mean, there have been a couple of, ironically enough, given the background of DevOps, a lot of the practices you can copy word for word, like, people and processes over documentation and tools and so on. So there's a lot of that mindset carries over. I think, some of the other ones that have come out, certainly more recently, are things like, bear in mind that the team isn't just development and operations, personal responsibility, ability to experiment, those kind of things. I think systems thinking is a classic one, like that is not explicitly stated in the Agile principles, but I think is very much a concept that DevOps comes up with a lot. And yeah, I mean, to some extent, but this is part of Agile as well. Like, we're friends, not enemies, basically. Ultimately, we're all trying to hopefully achieve the same thing. And to be honest, it's easy to say that we should all be focusing on delivering the end-to-end system, but in many organizations, that's definitely not how things are set up. So you can't really blame a developer for saying, like, you're not motivated to care about the system in production if it's an outsourced development company that gets paid when they deliver 35 function points and never get to see the system in production. So yeah, I mean, go back to your question. So I think that there have been, Gene Kim's written about a few things, John and Patrick Dubois, John Willis, Patrick Dubois, there's a lot of stuff out there that talks about individual practices that you can bear in mind or you can try to pick up. But to be honest, I think the Agile ones fit pretty well with the concept of DevOps.
You also talked about tools, that the tools, introducing tools is the first thing a lot of companies do. But what is the mandatory tool chain? Is there something like a mandatory tool chain for DevOps?
Yeah, I think there is. And I mean, I think, of course, there are always exceptions to the rule. But just in the same way as you would say in general that if you're doing software development, something like a source code repository, a build tool, and an issue tracker, you kind of need those to do, and an IDE, you need those to do development properly. I think in a similar way, there is very much a sort of pretty standard set of tools. Now, I'm going to name categories of tools, and in many, depending on your architecture, you may find that one product or one open source project actually fulfills multiple categories. So it's not necessarily the case that you have one tool per category, but the typical things that you see are, the obvious ones are environment, some cloud management thing. Pretty much all the DevOps stuff works on a virtual data center to some extent, whether it's public cloud or private cloud or whatever. Almost all the things that we try to do, like spin up environments quickly, do a lot of tests, it's very difficult to do if you're in a fully bare metal environment. Mm-hmm. So there's that kind of tooling. On top of that, potentially, depending on your tech stack, is some kind of environment provisioning tooling. So, if you're in a setup where instead of having a ready-baked VM or Docker container or something that has your entire application in it, but if you're in a setup where you're like, your company has a standardized Linux VM and a standardized Windows VM, and then when you ask for a server, you say, okay, give me a standard Linux VM, and now I'm going to put my standard app server configuration on top of it. So you typically have a tool like a Puppet or a Chef or a Salt or an Ansible or whatever to do that. That's very common. And then on top of that, again, depending a bit on this is more of a question of whether you make a conceptual distinction between your application tier and your platform, or whether you go for the more full stack development model. You might have a tool that, I like to call it, puts the icing on the cake, like spreads your application tier on top of that, because in most cases, app deployment is not necessarily the same as system provisioning. You might create an environment that will run for maybe a day or a week or whatever, but you might be deploying your application once per commit. And if it takes 25 minutes to spin up an entire environment, whereas changing a WAR file or a CLR thing or a DLL might take 25 seconds, clearly you need to think about the frequency. So there is the possibility of an additional layer of like application deployment tools. Ansible is used for that. I mean, people use things like Jenkins for that. There's a bunch of commercial tools for that. We have one of them, XL Deploy. So there's a few tools in that space. That's more looking at it from the system level, of course. Now I've talked mainly about what you would have in that testing and getting to production phase. Of course, once you're in production, you definitely need a bunch of monitoring tools. There's a lot of DevOps tooling around, like aggregating logs, things like Loggly or Logstash, or of course Splunk. There's more user level monitoring, the sort of APM style tools and New Relics and so on, that don't just try to tell you about how your servers are running. That's kind of moderately interesting from an operational aspect, but also how are your users using your application? Like, you decided that you were going to build this feature because it would mean you would get more customers in Japan or whatever. How do we know whether that's actually true? How do you find this out? So some people use Google Analytics, some people put a lot of monitoring inside. So there's that. And then of course, I'm going to shut up in a second, but I mean, we could go on for a long time, but I think at the high level, so the one thing that you still need is this end-to-end orchestrator. I mean, it's very nice to talk abstractly about the end-to-end pipeline, and you can draw it on a piece of paper, but at some point, if you're going to automate it, you need a tool that will actually orchestrate all the steps. I'm going to commit a line of code, I'm going to build it, I'm going to do some static tests. That's typically what a CI tool would do for you. But then I want to provision a new test environment, and then I want to deploy the application, and then I want to run some functional tests, and then I want to maybe do a review, and then I want to do some load tests, some performance tests, blah, 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 blah. And eventually I want to get this thing into production, and then I want to look at it once it's got into production to verify whether we need to roll it back or whether we're really happy with the result or whatever. So you need this kind of end-to-end process orchestrator as well.
Okay, interesting that also measuring user clicks is part of the DevOps toolchain.
Well, so again, I mean, I think this depends. You can have this, you'll get different answers depending on who you ask. I think certainly if you're taking the sort of continuous delivery process, like whiteboard to production time approach, to me this should be very straightforward. And it's not actually. This is, for a lot of people, the focus of this initiative is really about, like, how do I optimize my supply chain, like my production line? And I think it's a little ironic because, to think of any other production line. I mean, software is not the first industry to have the concept of a production line. Like, if you think about cars or T-shirts or whatever, most of these organizations spend a huge amount of money trying to understand how their customers react to their products. Because it doesn't matter if you can have the perfect production line to build cars in 3 seconds. If nobody wants to buy them, if they look terrible, who cares?
Exactly.
In the software industry, we spend a lot of effort and time right now talking about how to optimize this process of building the software and shipping it, but not a lot of time talking about understanding whether it actually is fit for purpose. Typically, the only time we find out if it's fit for purpose or it's not fit for purpose if it blows up. It's a very extreme case. So to me, this sort of notion of hypothesis-driven development, that when you actually start out with a feature, you should ask yourself, well, why are we building this feature in the first place? And that could be a very technical hypothesis. It could be that, if we implement this queuing mechanism, then we will be able to handle 50% more traffic with the same server load or whatever. But it can also be a very business level question. Like, if we move the shopping cart icon from the right to the left, we will get more customers in the countries where they read from the right to the left or whatever. So if you have that as an idea when you start, surely once you've shipped that stuff into production, you should try to ask yourself, well, was I right or was I wrong? And that's this sort of feedback loop concept that is that's been from part of the sort of agile and continuous delivery language from the beginning. It's not just about getting it from A to B, it's about learning from B and feeding that back into A. DevOps also has quite a lot of this. Often it's been more of at the sort of the team, the person level, like what from our system in production, what can we learn about how we developed it? But I think, as I said, to some extent, as teams get more comfortable with this notion of thinking of the end-to-end team or system or process, they start to think about what the purpose is of what we're doing anyway. And ultimately, the purpose is to ship good software to our customers, so our companies make more money, and everything is great. And then you have to start to think about this stuff.
Okay, you mentioned that it depends on the architecture, or it can depend on the architecture what tools I choose or not. Are there certain architectural styles which support DevOps, or architectural styles which are problematic for DevOps?
So this obviously, of course, goes back to the question of what DevOps is. Yeah, I think in any landscape, you can look at a system and ask yourself, where are our problems and what can we do better? But certainly, if you're taking as one of the goals, like reducing the error rate, increasing the speed at which we can do stuff, increasing the amount of time we have to innovate on our products rather than messing around with our systems, there's a couple of obviously big problem points. So the one is the classic monolithic system. Like, the bigger a system, to take a trivial example, if your system takes 8 hours to compile and ends up with a 5 gigabyte binary that includes half the internet, just the network time moving stuff around is already a problem. And potentially also the cost of downloading all this stuff. More realistically, systems that tend to be very large and contain many components, it's very difficult to make small changes to those systems. The environments they run in tend to be very complicated because they contain lots and lots of different parts. Some of the technologies are very hard to automate. Stupid example, but if you are running on a queuing service, a bus, a broke, whatever, which can't be put on a virtual machine, like the only machine it runs on is a mainframe, or you can't make an emulator for it, or the installer requires you to click through a manual wizard. Those are all things that definitely stand in the way of some pretty common goals for DevOps, such as automation, reducing error rate, and so on. I think right now, of course, the big hip architecture that people are talking about as solving all the problems where all our previous architectures have failed is microservices. And microservices definitely have a bunch of, if you like, built-in characteristics that supposedly make acceleration and DevOps and these kind of things easier.
Yeah, I heard that microservices are the first post-DevOps architectural style?
I was going to say the next silver bullet, but no. I mean, so I think there's definitely stuff in there, right? And I mean, ironically enough, they're not the first post-DevOps architectural style, really, because they've been running in some companies for like almost a decade now. Just people didn't know about it. But so I think there's definitely a few things there that can help a lot. The notion that you should write smaller components that are themselves easier to move around, more independent. So simply to answer the problem of, look, we need to get a test environment running where we can verify this stuff, doesn't take 5 people, 800 servers, and a week's worth of configuration. Those are all great enablers. Obviously, in terms of specific microservices related technologies, containers are things people are looking at right now, partly for this reason. It makes it very easy for you to encapsulate an entire system, move it around, have reproducibility across different systems, so you're not running on a different version of the kernel here versus there. One of the things I say quite often is that you don't need containers to do microservices. Ironically enough, a lot of banks have a very microservice style architecture, which is simply based on command line JVM apps. But they won't have them containerized. One server will be running 150 JVM or Java threads, basically, not in an app server, just simple. And there, to some extent, the JVM functions as Docker, if you like. Right? It's the thing that makes things portable. So there's a lot of interesting advantages there. I think there's a lot of new challenges that people are maybe wanting to ignore and are starting to see happen, because of course the reality is that typically in IT, so monolithic systems have a lot of, if you like, unnecessary complexity, caused just by all the different tools that are needed and then the different people involved and so on. Containers or microservices can definitely get rid of some of that complexity. But the thing that we sometimes like to forget is that some of the complexity in a big system is simply down to the complexity of the business process we are trying to model. So breaking apart an enormous monolithic application into 85 microservices will make some things easier, but those microservices still need to talk to each other. Like I like to say sometimes, no microservice is an island, so it wouldn't do very much. So we've, as a software development community, we've spent 15 years or so trying to figure out the problem of dependency management within our enormous, complicated monolithic apps, build time dependencies. And how we break them all down into microservices, so that removes a lot of the build time dependencies because they're small and simple, which is great. But now you have the runtime dependency problem. And if you like, proof for that statement is the fact that there's all these container orchestration frameworks which try to help you do exactly that. Understand that in order to get something that's workable running, you need 8 or 9 of these things, and you need different versions of them, and the versions have to be compatible. And all the same problems we know from like Maven, if you like, they come back, but they come back at runtime. So I think we're not out of that particular wood yet, but certainly I think smaller, simpler architectures can make the problem of getting from dev to ops a lot easier, because they also, going back to the problems that are common, not understanding how your system is running. Clearly, if you're running a container on your local machine on the same API, that's pretty much how it will run in production. You still have some latency issues and so on, but automatically you have a level of shared understanding that is better than in typical setups today, where you're basically running an app server inside your IDE, which is totally different from the way it runs on a production box.
I heard now, the tool chain, and it's easier to do DevOps if you have. It's probably easier if you do microservices. That all costs money, of course, to introduce. I'm just wondering, are the costs lower than the benefits?
The consultant answer applies as ever. It depends, right? I mean, who was it who said it? The answer to any technically interesting question is it depends. I think the problem here is that, I think with Agile, again, I think there's a lot of good lessons to learn from Agile. The early adopters the very early adopters do it out of some kind of, religious persuasion. Like, they don't really necessarily ask this question. They just do it because there's somebody with a lot of power or a lot of conviction that can get it done, and maybe the company's growing so fast that money doesn't really matter anyway. And then you get into that set of adopters who are not convinced by it, if you like, but who need a business case for it. They need to understand, what are we going to get out of it? And I think the risk right now is that a lot of people are doing DevOps because they read somewhere that doing DevOps is the next thing that they have to do. And the problem with that, of course, is that A, they don't really have a clear picture of what doing DevOps means, certainly not for them. And B, the answer often, when are we finished? It's like, when we've done DevOps, which is absurd, of course, because DevOps, like anything else, like Agile, should be a means to an end. Like, you should be employing these practices because they will help you with a problem you have. If you don't have a problem that you think this thing will solve, then you shouldn't be investing any time or any money in it. Like, if you're releasing software as fast as you need to, there's no production problems, your customers are happy, and you don't feel under competitive threat, then this is obviously not the thing to do. And I think there's a risk there because, just like we are seeing agile fatigue, a lot of people having invested a lot of money, as I said, in Scrum boards and Post-it notes, and really asking themselves, well, what have we actually got out of this? I think there's a risk that will happen with DevOps as well. And the best way to guard against this risk, as you said, is to have an idea of what you're trying to get out of it. And then going back to, culture of constant learning and experimentation. Once you have an idea of what your goals are and you have some kind of metrics that you are going to attach to those goals, then you can try something and you can start to see whether it's taking you in the direction that you want to go. And if it's not taking you in the direction you want to go, or if it's taking you in the right direction, but for every dollar that you make, you're spending $10 or whatever, then I think you really need to ask yourself, well, maybe this is not the right time or the place to be doing this. So to me, that is, starting out with a clear conception and a shared understanding of what your goals are and how you will measure them, and how far you want to get in 6 months and how far you want to get in a year or whatever, is absolutely essential.
Mm-hmm. And also draw the risks.
Yeah, of course, absolutely. Right? So if something blows up in production every single time, or people start leaving the company because they don't like this way of working, you really have to ask yourself whether this is the right thing for you to be doing. And so that, again, but obviously the risk, these things all go together. What we were discussing earlier, the notion that you should understand the principles, but you should not try to apply a sort of cookie cutter. This company did. Obviously, the more you are applying a cookie cutter approach, the bigger the risk that you don't have any business relevant goals of your own, the bigger the risk that you get frustrated because you're really just trying to follow a recipe rather than trying to optimize something that is relevant for you. I think the other risk, of course, with these things, but this is to some extent a human problem. The person who has pushed for this the most is probably the least likely to admit that it's not going well. So, and that only makes the problem bigger because you tend to dig yourself deeper and deeper into the hole before eventually it becomes clear that you're stuck and it really is such a disaster that you have to give up. Part of constant experimentation and learning is, admitting that the path we tried isn't the right one, then we try something else. And that's not in contradiction to DevOps. Ironically enough, it's not even in contradiction to something like ITIL or ITSM, which were often regarded and which suffered from this a lot as being incredibly prescriptive. Like, the way to do it was you bought the book, and the book told you exactly what you needed to do, and you had to produce 87,000 documents and so on and so forth. Of course, if you read somewhere in the fine print, it said, these are all suggestions, pick and choose the ones that make sense for you. But that's, of course, very hard to do. It's much easier just to look at the book and to buy the software package. And because the software package has a text field for this particular document.
Exactly.
So that I think that's, of course, a big risk with DevOps as well. And that will only increase because, as we see, the more, especially the big vendors, see that there's money to be had here, the more you see discussion of things like DevOps stacks, DevOps clouds, DevOps this, DevOps that, DevOps center of excellence, where somebody sees, we can make 50,000 or 50 million euros by selling this company DevOps out of a box.
What about a DevOps team?
So basically, yeah, there's a bunch of very funny rants about this. Like, there is no such thing as a DevOps team. I think one of the famous ones says something along the lines of DevOps basically means that you care enough about your job to give an effing damn, right? So, and yeah, that gets back to, I think that it's much more of a mentality, a mindset. But DevOps team, well, I have sympathy with this a little bit. I think that the problem is, of course, that, really the people who do a lot of the tooling work in DevOps are really an ops team. Like, they're a platform team or system reliability engineers or whatever you want to call them. I don't think that matters so much what you call them. I think that the problem is that for a lot of people, ops starts to sound like the old-fashioned, like, rack and stack type people. And so in order to upgrade my CV, because I can code a bit and I've learned how to use Puppet or Chef or whatever, I need to call myself a DevOps engineer. And we can argue long and hard about whether this is right or stupid or whatever. Reality, to some extent, has overtaken us. So I think when you talk about people, DevOps really means have knowledge of a particular tool set, a particular skill set, and it's typically around being able to use virtualization technologies and the new sort of breed of ops tooling in an effective way. Basically, understanding development in the ops space. I think, yeah, I would rather obviously have, a bunch of, if you're going to talk about something like a DevOps team at all, they probably should be something like a roving band of gurus, if you like, who go around the company trying to help people understand the mindset, more like coaches or trainers.
Okay. Do you have materials on DevOps you want our listeners to know about?
There's so many. I think if you're interested in getting a feel for the sort of flavor of DevOps and the mentality of some of the people who came up with a lot of these ideas, Patrick Debois' blog post is a great place to start. Gene Kim's obviously written a lot about this recently. John Willis and John Vincent are both interesting people to listen to. There's the DevOps Cafe. There's some interesting podcasts there. I think if you want to get more into I want to convince my management of this, what are the business cases, what are the arguments I can take to them that will give me firepower to make this thing happen in my company. There is actually some reasonably good research from some of the bigger analysts like the Gartners and Forresters talking about the return on investment and all these boring terms. And again, if you're trying to do something for your manager, more likely than not, they will not be able to tell the difference today between DevOps and continuous delivery. So also look at some of the sort of IT manager's guide to continuous delivery is a nice short one. I mean, obviously, disclaimer, I'm one of the co-authors, so we try to distill some of this stuff into like an 80-page guide for some managers and this kind of stuff. I think that maybe the best thing you can do in terms of a fun, interactive experience is go to a DevOps Days. DevOps Days is a great 2-day event. Obviously, there's a ton of meetups you can go to as well, but DevOps Days are kind of all over the world. They're 2 days. They're a community kind of conference. There's some discussions. There's some open spaces. And you'll really get a feel for the kind of people that try to make up DevOps. And hopefully, you'll realize most likely that there's much more doers there than deciders, than decision makers. It's not like a sort of, I would think of it an opposite end of the spectrum. Some of those conferences where you really only see sort of VP of whatever running around trying to get ROIs. It's a fun place to be.
Okay. Thank you, Andrew, for being on the show.
Thank you very much, Sven.
I want to mention that the feedback of our listeners is very important to us. So please help us improving our show and leave your opinion via Twitter, G+, or LinkedIn. This is Sven Johann for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.